Let's take a look at visualizing these relations. So this is the example that we just did in the last video, that if A is the set containing 1, 2, 3, and 4, and we define this relation of, we have the ordered pairs of A comma B where A divides B, then we found this list of all of the elements that are described in this relation R. Visualizing this, what we could imagine is that we would have, say, the numbers 1, 2, 3, and 4. And then we could say, how do these relate to themselves? So we could also imagine this as being 1, 2, 3, 4. And so we could draw little arrows of saying, which of these numbers is 1 related to? Well, we have 1 is related to 1. We have 1 is related to 2. 1 is related to 3. And 1 is related to 4. Similarly, you could see that 2 is related to 2, and 2 is related to 4. Then we saw that 3 is related to 3, and 4 is related to 4. So we could visualize this process of seeing these elements as kind of this map of, you have the set A, trying to see what is this related to in the set A. So you can say, okay, well, this is kind of like A, and this is kind of like A. So if you had two sets, A and B, and you want to talk about the relation on A cross B, you could then define this as being A and then B, and then seeing where these go together. So again, like I said in the first video of this chapter, you should have automatic kind of response that, is there something related to functions going on here? So let's do a little bit of a brief recall. So recall, we said a function that maps the set A to B is a subset of A cross B satisfying a certain condition. Now, we could have A get mapped to A, and then we're looking at the subset of A cross A. We see that many times, right? You may look at a function where it maps the reals to the reals, or one that maps all non-negative real numbers to non-negative real numbers, or you could map Z to Z. Okay, so what we should be able to see from here is that functions are relations. So remember, when we look at these, I guess, categories of what is one in comparison to the other, so you could say all squares are rectangles, but not all rectangles are squares, right? So all functions are going to be relations, but not all relations are going to be functions. So functions are relations. The only big difference here is that when defining a function, the relation must have special properties. So when we talk about these special properties here, what we said is, for it to be a function, that means that every element in A has to have something corresponding to it in B, and that something in B can only be one thing. So if we think about relations and functions, we see this does not describe a function. This is a relation, but obviously it's not a function. It's fine because every element in this case, if we think about a domain, you think about every element in this set here, it has something that's being mapped to, but the problem is that this is being mapped to multiple things. So this relation does not describe a function, but every single function that we've studied so far in this class is a relation. So many times, if you look at textbooks of college algebra or pre-calculus, you're going to see they'll try to introduce functions by using relations. So if you want to be a high school teacher at some point, or you're going to be teaching, say, a college level class in math, you will probably have to make the decision, do you want to introduce functions by introducing relations first? So these do often get taught sometimes in high school and different introductory level college courses. But for our understanding, we have already studied functions. We didn't need relations to get there, but we're going to do some fun things with relations, but just make sure you keep that in the back of your mind, that by studying relations, we are studying functions because all functions are relations.